The topic is writing equations to represent proportional relationships. The essential question is, how do you write equations to represent proportional relationships? So the notes say when you have a situation that shows a proportional relationship, this is how your equation should look. So when you know it's proportional, you would have right here y equals k times x. And I know that kind of sounds a little bit confusing right now because all of it is just variables. So we're going to go ahead and label these to hopefully break it down for you, okay? So the y will represent your dependent variable. Okay, and this x right here, that's going to represent your independent variable. And of course, this k right there, in place of that k, you're going to put the unit rate, okay? But you're going to have a number for k right there, but you're going to keep your y the same and your x the same, all right? For now. So number 1 says the cost of renting a snowmobile for 5 hours is $37.50. Use x to represent time in hours and y to represent cost in dollars to write an equation for this situation. So I'm going to underline some key important information right here. I see that 5 hours costs $37.50, you know, to rent that snowmobile for 5 hours. That's how much it costs. They want us to use x to represent time in hours, and they want us to use y to represent cost in dollars. Okay, so just like above right here, we're going to go ahead and start with writing y equals unit rate times x. So I'm going to write y equals, and I'm going to leave a box for the unit rate because we're going to go ahead and find the unit rate in a couple moments, okay? Now that we have these variables in place, the dependent variable and the independent variable, we're going to go ahead and label those. So the x represents time, and I know that because it says it right here. Use x to represent time in hours. So that's time, and if you want, you could put hours, so you're more precise. And then this y, which is the dependent variable, that represents cost in dollars. And in parentheses, I'll just put a dollar sign right there so you know it's in dollars, okay? So this kind of makes sense that this is y, it's the dependent variable, and x is the independent variable, because doesn't the cost depend on how many hours you spent renting it? All right, let's go ahead and let's find the unit rate right here. And since there's not much room over here to find the unit rate, I'm going to go ahead and write it over here. And I'm going to use the information provided within the context of the problem. To find unit rate, you should hopefully know by now that it's y divided by x, your dependent variable divided by your independent variable. And the information that I have right here is $37.50 for the dependent variable. And make sure you label that as money. And then we have, for the independent variable, for x, we have 5 hours. And that right there is just the rate. That's not the unit rate. For the unit rate, you need to have 1 in the denominator. So I'm going to go ahead and set up a proportion right here. And I want 1 in the denominator. So to go from 5 hours to 1 hour, we just divided by 5, because 5 divided by 5 is 1. So I'm going to also do that to the numerator, okay? $37.50 divided by 5. Let me go ahead and plug that in real quick. I got $7.50, 7.5, so $7.50. So that right there is the unit rate. You know, this situation right here was the rate, and this right here is the unit rate. So I'm going to go ahead and, you know, that spot we reserved for the unit rate, we're going to go ahead and plug that in right there. And just to save some room, instead of writing 7.50 for $7.50, I'm going to write 7.5, 7 5/10, because that's the exact same thing. And I'm just going to go ahead and label that right there so you know that's the unit rate. And that unit rate, just so you know, it's $7.50 per hour, okay? Okay. So now it says how much would it cost to rent for 3 hours. So you're going to rent that snowmobile for 3 hours. And we know that 5 hours cost this much, so we got to kind of break it down to figure out how many 3 hours would cost. And I want to show you 3 different ways to do this problem. Okay, we've talked about many different ways to figure this out, and I'm just going to show you that there's at least, there's more, but there's at least 3 different ways to solve this problem. And the first way I want to show you is just using this equation, okay? So the first way, I'm going to write using equation, and then I'm going to show you how to do that. All right, so right up here we have the equation, and it's really nice that you have it already labeled. And please always label, because later on in the future, it's always going to help you, okay? So I'm going to write down y equals, I wrote down y, I kept it y because we don't know the cost. See how it says how much would it cost to rent for 3 hours? I don't know the cost, I don't know the y value, so I'm going to keep it as a variable, okay? We do know what the unit rate is. And then right here where it says x, I'm going to substitute the time in, and it says 3 hours. So see how it's labeled 3 hours? Well, this is time in hours, so instead of the x, I'm going to write the number 3 right there. Only I'm going to do it down here, okay? And when they're smushed next to each other like that, you have a coefficient and a variable, that means multiply. Okay? So y is going to equal whatever 7.5 times 3 is. And I got $22.50. So y is the cost. So it would cost $22.50 to rent for 3 hours. There's my answer. Okay, that's one way to find it, and I'm going to show you 2 other ways to find it. Another way is just using proportions, setting up those equivalent fractions. So I know that my unit rate is $7.50 for 1 hour, but since they're curious about 3 hours, I want, hours in the denominator. And we got to figure out the corresponding numerator, okay? So 1 hour costs this much. We want to know about 3 hours. So right here, I've got to multiply by 3. 1 times 3 is 3, so I have to also do that to the numerator. $7.50 times 3, well, you're also going to get $22.50. That's my answer right there. Okay, the third way that I'm going to show you is just using a table. A fourth way I could show you is by creating a graph, but I just don't have room for that, okay? Using a table. All right, so I'm going to go ahead and set up x and y. But remember how I'm very, very strict on making sure you label. So x represented time, and if you're like, oh, I forgot what x represented, it's right there. It's also up there. It's also over here. Okay, so x represents time in hours. Y represents, well, let's look. Oh, cost, cost, cost. So see how it's very consistent with what you've already labeled. Okay, so the information they gave me was, well, for 5 hours, it costs $37.50. For 1 hour, we found was $7.50. And they're curious about right there 3 hours, so I'm going to put a 3 right there, and we're going to find its corresponding y value. So you'll notice within this table, we're just multiplying by the unit rate every time. 5 times 7.5 equals $37.50. 1 times 7.5 is $7.50. So I have to go 3 times 7.5. And when you go 3 times 7.5, which is the same as 3 times 7 and 5/10, you will get $22.50. Look, there's your answer again. So I've just shown you 3 different ways to figure out to get the same, to use and to get the same exact answer. Okay, for your summary, I want you to rewrite this. I want you to rewrite the question, because if you just write yes or no without the question, then it's confusing. So is y equals k times x equivalent to k times x equals y? Answer that, and then move on. Number 2 says, write an equation where x represents gallons and y represents distance in miles to model this proportional relationship. So before I really get started with reading that, I want to probably underline this important stuff right here. It represents gallons, and then for x, and then y represents distance in miles. Okay, so we're going to model this proportional relationship by creating an equation. If you have 12 gallons of gas, your vehicle can travel 132 miles. Okay, if you've got 12 gallons of gas, your vehicle could travel 132 miles. What we need to do is remember that equation that we want to set up. We're going to go ahead and kind of put the skeleton down of it. So y equals, let's leave a box for the unit rate, times x, okay? And x is the independent variable, and that will represent gallons. And then y is the dependent variable, and that represents the miles. So all that we have left to find is that unit rate. So I'm going to draw an arrow there because I know that's going to be the unit rate. But now we just have to find it. Okay, so since there's not much room, I'm going to write it over here. And to find unit rate, you need to go y divided by x. Okay, and y would be, the dependent variable is going to be the miles. So we have right here 132 miles, that's distance. And you're going to label it. And you can go 132 miles on 12 gallons of gas. I'm just going to write gal, G-A-L, for gallons. Okay? Well, that right there, that's just the rate. We need to find the unit rate, okay? So I want to figure out how far they can travel on 1 gallon of gas. So to go from 12 to 1, we divided by 12. And the numerator we also need to divide by 12, so 132 divided by 12 is 11. So our unit rate is they can go 11 miles on 1 gallon of gas. So now we're going to go on back over here into this box, and I'm going to put the 11 right there, okay, because that's my unit rate. And in parentheses, I'm going to write that the unit rate was 11 miles per gallon. Okay, so now that we have this equation all figured out, now we can answer these other questions. And I know on the first page I showed you 3 different ways to do that. For these next problems, I want you just to use the equation, okay, just so you can get some practice with that, just because it's, it's brand new for you. How many miles can it travel on 2.5 gallons of gas? So using this equation, we're going to figure out how many miles that car can go, or your vehicle can go on 2.5 gallons of gas. So since it says right here 2.5 gallons, I'm going to substitute that 2.5 gallons right here because it's really important that you label. If you label it, it's easier to substitute values in. So instead of writing the x when I write this out, I'm going to write 2.5, okay? I'm going to keep the y as a variable because I don't know how many miles that is yet. I'm going to keep the 11 there because that's the unit rate. And substitute that 2.5 in right there. And when we do that, we can figure out how many miles it can travel on 2.5 gallons of gas. So I need to just go 11 times 2.5. Go ahead and do that. Okay, I got 27.5 miles. Okay, that's how far it can travel on 2.5 gallons of gas. All right, if the vehicle traveled a distance of 60.5 miles, how many gallons of gas were used? So I'm seeing that it's giving us 60.5 miles. That's how far it traveled. So go back up to your original equation up here. Look how it's labeled 60.5 miles. Is 60.5 miles, is that going to go here under gallons? No, because those don't match. Right here, 60.5 miles goes where the y variable is, okay? So instead of putting the y, I'm going to write 60.5. And 60.5 as a decimal would be 60.5. So I'm writing it right there, 60.5 equals, I'm going to keep the exact same unit rate. And we don't know how many gallons of gas were used, so we don't know that, so we're going to keep it as a variable, okay? So right here, we're just kind of solving for it. And what you would hopefully remember from previous lessons is how to build it. So folks, we had started with x, then we multiplied it by 11. So the inverse operation of multiplying by 11 is to divide by 11. So that's what we're going to do to both sides of that equal sign. Okay? 11 divided by 11, well, that's 1. 1 times x is x. And 60 and 5/10 divided by 11, that's what I got to figure out. So go ahead and type that in yours as well. And I got 5 and 5/10. Okay? So x is 5 and 5/10. But you need to remember what x stood for. X represents gallons. So 5 and 5/10 gallons. Okay? All right, the next problem. It says, a person who weighs 100 pounds on Earth weighs 16 and 6/10 pounds on the moon. That's cool. Write an equation to show how much a person would weigh on the moon for every 1 pound on Earth. Okay? You'll notice that this problem has nothing to do with distance, cost, or time, so you really need to rely on what you know about unit rate. So, according to this, they want pounds on Earth in the denominator, okay? So let's go ahead and let's set up our skeleton equation. I don't know why I call it that. I just kind of call it that just because there's no numbers really quite in it yet, okay? So we're going to start with y, leave room for our unit rate, and have our d independent variable right here. And that x, the independent variable, is representing, oh, it doesn't say yet. Huh. Well, we'll come back to that later, okay? Use what you do know, though. So let's go ahead. We need to find that unit rate. So unit rate is y divided by x, okay? Now think about it. You want pounds on Earth in the denominator, so I want that on the bottom. How many pounds on Earth? Okay, so 100 pounds on Earth. I'm just going to write Earth. And when you're 100 pounds on Earth, you weigh 16 and 16 pounds on the moon. 16 and, did I say 16 6/10 pounds? That's what I meant to say. So I'm going to write moon. And I should actually label it pounds. LBS. LBS. Okay? So that right there, it's not the unit rate. That is a ratio because they're both in pounds. Now we need to find the unit rate. So we want 1 in the denominator. 1 Earth pound. And what we need to do to go from here to here is we need to divide by 100. And also same with the numerator. So 16 and 6/10 divided by 100. Is this 166 thousandths. And that's going to be moon pounds. Okay, so that right there is our unit rate. So now I'm going to go over here, and I'm going to write that unit rate in right there, 0.166. Okay, 166 thousandths. Okay, now remember how I had a little bit of trouble with labeling it? Now that we have it already over here labeled, now it's going to be much easier to transfer the information, okay? So x represents, well, remember x is in the denominator, that represents Earth pounds. So I'm going to label that as Earth pounds. I'm going to use LBS for pounds to abbreviate. And then y, let's look at y. Y is representing moon pounds. And that's what I'm going to do over here is label that. Okay, so there's our equation, and we need to go ahead and figure out how much they would weigh, how much would they weigh on the moon for every pound on Earth. So if they weighed 1 pound on Earth, how much would they weigh on the moon? Well, that's your unit rate. Here's 1 pound on Earth. They would weigh this many moon pounds, okay? They would weigh pounds on the moon. And another way you can do that is if they weighed 1 pound on Earth, you can substitute a 1 in right there and just go like this. Y equals 166 thousandths times 1 pound on Earth. That's 1. And you just multiply, okay? So we have 166 thousandths times 1. You should know this. Times 1 equals that. Okay? So they would weigh that much on the moon. All right. Now let's go ahead and use that same equation to figure out the rest of the problem. If a person weighed 34 pounds on the moon, how much would they weigh on Earth? All right, so they're weighing 34 pounds on the moon. So let's look back up at this equation right here. Where do you substitute the 34 pounds? For the moon or for the Earth? Well, since it says 34 pounds on the moon, we are going to substitute this 34 right there for y, okay? So instead of writing the letter y, you're going to put 34. You're going to keep the exact same unit rate. And we got to figure out the value of x. We need to figure out how much they weighed on Earth, okay? So when you can build this, you start with x. Then after that, we multiplied it by 166 thousandths. The inverse operation of multiply is to divide, so we're going to divide both sides by 166 thousandths. Okay, 166 thousandths divided by 166 thousandths is 1. 1 times x is 1x, or x. And then 34 divided by 166 thousandths is, I don't know. I got this, okay? So I'm going to go ahead and let's round it to the nearest hundredth. 204 and 82 hundredths, okay? Because right here is the hundredths place. You look behind it. If it's 5 or above, this 1 turns into a 2. So that's what I'm going to write. 204 and 82 hundredths pounds on Earth. That's how much they'd weigh on Earth if they weighed 34 pounds on the moon. Okay, let's go ahead and look at the next problem, number 4. To make 12 dozen cookies, you need 8 cups of sugar. How many dozens of cookies can you make per cup of sugar? Write the relationship as an equation. So we're going to go ahead and write our equation right here. Y equals, leave a spot for that unit rate, times x. And you know how this problem has nothing to do with distance, cost, or time? So it might be a little bit more challenging to figure out which one's the independent, which one's the dependent variable. So what you could do right now is just don't label them yet until you find your unit rate. So let's go ahead and find the unit rate. It's y divided by x. Okay, so what's happening here is the amount of the dozens of cookies depends on how much sugar you've got. So I want the dozen cookies in the numerator. 12 dozen cookies. I'm going to abbreviate like this. And to get 12 dozen cookies, you need 8 cups of sugar. Okay. I also knew that sugar went in the denominator because it says per cup of sugar. So sugar goes in the denominator. Okay. So right there, that is the rate. So now we got to figure out the unit rate. So you want 1 in the denominator. We want to know how much per 1 cup of sugar. So I'm going to divide by 8, divide by 8. So 12 divided by 8. I got this, 1 1/2, 1 5/10. So 1 5/10 dozen cookies per cup of sugar, okay? Make sure you have your decimal right there. So now, when I go back over here to this equation, I'm going to put that unit rate right there. And I'm going to go ahead and label that right there. So unit rate, which is 1 5/10 dozens of cookies, per cup of sugar. Okay, and since I'm going to need to label that x, I can go back over here to my unit rate. And so x represents the cups of sugar. And then y is going to represent the dozen cookies. How many dozens of cookies? Okay. So how many dozens of cookies can you make per cup of sugar? Well, you can make 1.5 dozen cookies per cups of sugar, okay? You can make 1 5/10 dozen cookies per cup. Uh-oh, I ran out of room. Per cup of sugar. Sorry about that. Okay, if you make 14 dozen cookies, how many cups of sugar were used? So you see how we have 14 dozen cookies right there? Go back up to that equation and think of where you would substitute that 14 in, for the y or for the x. It helps if you read it, 14 dozen cookies. Well, this y represents a dozen cookies, so instead of writing the y, I'm going to substitute and put that 14 right there, okay? So I'm going to write 14 equals, keep your same unit rate, and we need to figure out how many cups of sugar were needed. So now we're just going to solve it, okay? So when we built it, we started with x, then we multiplied it by 1 5/10. Inverse operation multiplying by 1 5/10 is to divide by 1 5/10, and that's what you do to both sides of that equal sign. 1 5/10 divided by 1 5/10 is 1. 1 times x is 1x, or x, same thing. And we got to go 14 divided by 1 5/10. 14 divided by 1 5/10. I got this. So I'm just going to round it to the nearest hundredth, 9.33. And when we label it, make sure you read it. What did x stand for? Oh, cups of sugar. If you want the most precise answer, it would be 9 1/3 cups of sugar, okay? Because 1 divided by 3 is 0.33333 repeating, and that's something that, I mean, hopefully you can memorize someday. 1 divided by 3, see there. So I know that 9 1/3 is more precise than 9.33 because this right here was rounded, this right here is precise. You need 9 1/3 cups of sugar to make 14 dozen cookies. Okay, so for your summary, I want you to please answer this. You should always label your equation because, so write this sentence starter and explain why you should always label your equation. Number 5 says, write an equation to represent the table. So I'm looking at the table right now and I want you to write x above this first column. These are all the independent variables. And this right here is y. These are all dependent on this, okay? So it looks like if you had 2 gallons of gas, you can go 62 miles. If you had 4 gallons of gas, you can go 124 miles. So you'll see that your miles driven depends on how much gas you've got, okay? So let's go ahead. We need to first figure out if this is even a proportional relationship, okay? So I got to go y divided by x for each one of those values in the table. Skip the 0, 0, 1 because you can't divide by 0. So y divided by x, so 62 divided by 2. That's 31. So I multiplied that x value by 31. 124 divided by 4. That's also 31. So this is looking like it could be proportional, but we got to check that last one right there to make sure we didn't mess up or make sure it's not proportional. I mean, to make sure it's not a non-proportional graph. Oh, okay. So it is proportional. We're good. Okay. So to write that equation, let's go ahead and start with, y equals, leave a spot for your unit rate times x. And, well, we have our unit rate, so we can put that 31 right in there, okay? Now, to label x and y, when you've got a table, you just look at the table. Look, that's already x, so x represents gallons of gas. And then y represents the miles driven. And then that 31, of course, is the unit rate. And that would be 31 miles per gallon. Okay? So if there were 30 gallons of gas, how many miles could be driven? And I do want you to use your equation, but you have a table right there that could also help you. So it says if there are 30 gallons of gas, let's go ahead and we can add that to the table. There's gallons of gas, we can put the 30 right there. And you should hopefully know that you would multiply it by 31 to get the corresponding y value. And 30 times 31 is 930. So you could go 930 miles, okay? But let me go ahead and show you using the equation because that's, the new thing that I'm introducing to you. So you obviously need practice with it. So it's asking about, they're giving you the information of 30 gallons of gas. So 30 gallons, does that go under miles driven or gallons of gas? Well, judging by the wording, 30 gallons goes with the gallons. So I'm going to write, keep y as a variable, keep your unit rate, and instead of writing x, I'm going to write the number 30. Okay? And if you're curious why I put the parentheses on there, it's because I know I need to multiply. Because if I put 3130, then that would be so confusing. So that just signifies, hey, multiply it. Because when we have these right here together, that means multiply. So I'm just continuing it down here, multiply. So 31 times 30 is 930. But make sure you label it. It's asking about how many miles could be driven. So 930 miles could be driven on 30 gallons of gas. All right, number 6. Write an equation to represent the table. Well, before you can write an equation, let's go ahead and make sure it's proportional. All right, so x and y. So the page is red, depends on how much time you've got, okay? So we got to go y divided by x, so 208 divided by 8. I got 26. Oops, wrong one. 208 divided by 8 is 26. Sorry. 156 divided by 6. Oh, that's also 26. And 234 divided by 9. That is also 26. So take a second right now, and I want you to go ahead and write out the equation. Please, write out the equation. Start with that, skeleton, like this. Y equals, leave room for your unit rate times x. The unit rate was 26. And x represents time in hours. And y represents the pages red. And that 26 is that unit rate, which is, you read 26 pages per hour. Okay, so now let's go ahead and answer this question. If they read for 6.5 hours, how many pages were read? So you'll see up here in the table, I don't see a 6.5, and you could totally add it right there. And then continue with the pattern times 26. 6 and 5/10 times 26 is this, 169. But I do want you to practice using the equation, please. So let's go ahead and see where this 6.5 hours goes. Okay, let's go ahead and see how you labeled it. Is 6.5 hours a page is read? Nope. 6.5 hours, that's a time. So we're going to substitute it for x. Okay, so I'm going to keep y the same. Keep that unit rate. And instead of writing x, I'm going to write the 6.5. Okay, so 26 times 6.5. Let me double check that. I got 169. And let's label it 169 pages were read in 6.5 hours. Okay, number 7. Write an equation to represent the table. So it looks like we have 6 ounces of coffee costs $2.10. 8 ounces of coffee costs $2.80. 16 ounces cost $5.60. So that price depends on how many ounces of coffee you get. So let's go ahead and still label it X and Y. And let's determine and see if it's a proportional table so that you could write an equation, okay? So I got to go Y divided by X, so $2.10 divided by 6. 2 and 1/10 is the same as $2.10. Okay, $2.10, same thing. So 2.1 divided by 6 is 35 cents. So I multiplied X by 35 cents. And I got to go $2.80 divided by 8. 2.8 divided by 8 give me the same thing, times 35 cents. Now $5.60 divided by 16. And that is also 35 cents. So this is a proportional table. So let's go ahead right now, write your equation. Y equals, and you don't really have to leave the box there because you see it right there. So 35 cents times X. And luckily you labeled X and Y, so now it's just super easy to label X and Y in your equation. X stands for ounces of coffee. Y, the dependent variable, is the price in dollars. That's a dollar sign. And that 35 cents is the unit rate. And that would be 35 cents per ounce. Okay, costs 35 cents per ounce. So what's the price of a 20 ounce coffee? So if you purchased a 20 ounce coffee, how much would that cost? So let's go ahead and look at our labels. 20 ounce. Is 20 ounce a price? Nope. 20 ounce an ounce? Yeah. So we're going to substitute this 20 in for the variable of X. Keep the Y the same because that's unknown. We don't know the price yet. Write down your 35 cents and multiply it by 20. 35 hundredths times 20. $7. Okay. $7 would be the price of a 20 ounce coffee. And you'll notice I didn't put that in the table yet because I wanted you to, try that equation. So let's go ahead and put that in the table. So 20 ounces right here, 20. And you'll see we had to multiply that by 35 hundredths, or 35 cents. And when I go 20 times 35 hundredths, we get the same thing. Yep, which is 7. Sorry, it's hard to write with one hand, not holding the paper. All right, for your summary, I want you to answer this. Which variable is the independent variable? Which variable is the dependent variable? Number 8 says, write an equation to represent the graph. So let's go ahead and examine the graph real quick. Let's see, is it linear? Yes. Does it pass through the origin? Yes. Therefore, this is a proportional graph. It's got to meet those two criteria, be linear and pass through the origin in order to be proportional. Well, I see that it could use some labeling. Right here, this axis is the x-axis, and this axis right here is the y-axis. All right, so the x-axis represents sales by an online music store. So that could be like iTunes. So let's say iTunes. They sold $200 worth of stuff. Well, this is how much gets paid to the pop star of the songs that were purchased. They would only get, and see how you can't really see how it goes to it? It was really kind of these people that made this to write that. So 40 bucks. So if iTunes makes $200, $40 of that goes to the pop star, okay? This one I don't exactly know for sure, so I'm not going to try to label that. Right here it's already labeled, so if an online music store made $600, then $120 goes to the pop star, and this one's blank, and then this one right here, if the online music store like iTunes made $100, $200 goes to the pop star, okay? So let's go ahead and write an equation. Since we know this is a proportional graph, we can take any one of these values right here and figure out the unit rate, okay? I don't care which one you pick your favorite. I don't have much room, so I'm going to write it over here on the left-hand side, and I'm just going to write y divided by x for the unit rate, okay? I'm just going to go with this one. Y is 40. And well, Y represent 40 is pop star. I'll just write pop. And then right here, the 200 is the X. And that goes to the store. Okay? So for this ratio, since they're both in dollars, we need to figure out the unit rate from this ratio. So I want to know if the store made $1, if the store, if the store sold $1 worth of stuff, how much does the pop star get? So to go from 200 to 1, we just divided by 200. So we also do that to the numerator. So 40 divided by 200, let's figure that out. And I got 2/10, which is 20 cents. Okay, so now that I have the unit rate right there, I can write the equation. So start off with y equals, now we got the unit rate, 20 cents, so 0.2 or 0.20, same thing, times x. And if you're curious, well, what do I label the independent variable and the dependent variable? Remember how you labeled this right here? Here we go. So x is this. X is the sales by an online music store. Sales by store, and that's in dollars because I see that there's dollar signs on there. And then that y, which is the dependent variable, is, here's my y, it's the paid to the pop star. Paid to pop star, so the singer. And that's in dollars also because there's dollar signs, okay? So now it says if the online music store sold $500 worth of items, how much would the pop star get? So I'm going to go see here if that's even on my graph. $500 would be like right here. And I don't know exactly for sure. That's about $500. I think it would be 100 would be paid to the pop star, but I don't know for sure. So therefore, it's always good that you have this equation. So the online music store sold $500 worth of stuff. Where would you substitute that $500 for? Right here, sales by the store, or right here, paid to the pop star? Think about it. It would go right here, sales by the store. So I'm going to copy down that equation, keep the variable of y the same, because we don't know how much is paid to the pop star. We don't know that. So we're going to keep it a variable, because it's the unknown. And I'm going to keep that unit rate, and instead of writing the x, I'm going to write 500 right there. Okay? So now I would go 20 hundredths times 500, or you could do 0.2, same thing, times 500, and I got $100. Dollars would be paid to the pop star. So if you're ever in doubt with that reading your graph, use your equation, okay? So if, you know, like how I said, I wasn't sure if it was exactly 100, it was. But it's better safe than sorry, especially on assessments, okay? All right, let's go ahead and look at the next problem, number 9. And it doesn't look like there's any information right here, but they want us to have an equation, and let's examine this this graph. I see that it is linear, meaning it forms a straight line and it passes through the origin. So this right here is a proportional relationship. And we have x representing the number of hours, that x-axis, and then the y-axis is representing the amount of pay in dollars. So it looks like if a person worked 1 hour, they would make $8. If they worked 2 hours, they'd make $16, and so on and so forth. If they worked 0 hours, they'd make no money. So I'm going to go ahead and label this ordered pair right here as 1, 8. This ordered pair right here, see how they're at perfect intersections with the grid? Those are easier for me to figure out, 2, 16. You know, there's a point right here too, but I don't know what the x value is or the y value is. All these right here are points, and they're so close together that they form a line. Because like if you worked for 1 hour and 20 minutes, you'd still make a certain amount, okay? But since it's not at a perfect intersection with the grid, I can't provide ordered pairs for that because it wouldn't be precise. It would just be kind of like a guess, okay? All right, so let's go ahead and write the equation. Y equals, I'm going to leave a space for the unit rate because I don't know the unit rate yet, times x. Y represents the amount of pay in dollars. So I'm just going to write pay, dollars. And then that x represents hours worked. Okay, let's go ahead and find the unit rate. Since this is a proportional table, you can pick either one of those values right there to help you with the unit rate and pick your favorite. So unit rate is y divided by x. It's kind of nice. I see this right here. I see that x is 1. So after 1 hour, they would make $8. So that's kind of a hint to myself, hey, that's the unit rate. That 8 is the unit rate, okay? So I'm going to use that one. Y is 8, x is 1. So $8, because that's dollars, per every 1 hour. That's the unit rate. So when I walk on, I mean not walk on, but when I move my paper back over here, and I got 8 for the unit rate. So I'm going to label that unit rate. And that would be $8 per hour. Okay, so if Amber was paid $96, how many hours did she work? So she was paid $96. So I'm looking at the pay, and it's not on the graph, so therefore I'm gonna need to use my equation, or you could totally use a proportion. But since we are practicing with equations, that's what I want you to use, okay? So I'm gonna go ahead and figure out where that 96 goes. $96. Is that a pay or is that the hours? Well, since there's a dollar sign, I'm gonna plug it in for the value of y. So instead of writing the letter y, I'm gonna put a 96 there. Okay, I'm gonna keep the same unit rate. And I don't know how many hours she works, so I'm gonna keep that as a variable, okay? So I'm going to build it. So we started with x, then we multiplied it by 8. So the inverse operation multiplying by 8 is to divide by 8. So we're going to divide this side by 8 and this side of the equal sign by 8. 8 divided by 8 is 1. 1 times x is 1x or x. 96 divided by 8 is 12. And it says how many hours did she work? We would put 12 hours. She worked for 12 hours to make $96. Okay? So your summary, how do you know if a graph displays a proportional relationship? What 2 criteria does it have to meet? All right, number 10 wants us to write an equation based on this graph right here. So I'm going to go ahead and look at the graph, and is it proportional? Yes, because it's linear, it forms a straight line and it passes through the origin. So therefore, this is a proportional graph. I see that the x and the y-axis aren't labeled yet, so I'm going to go ahead and label them right now. And I'm going to get started on this equation, okay? So it's going to be y equals, I'm going to leave a spot for the unit rate, times x. And I can start labeling right now because it's on my graph. So x stands for, let's look at the x-axis, time in seconds. Time in seconds. Okay, and then the y-axis is distance in feet. So I'm going to write distance in feet. Okay, now let's go ahead and figure out the unit rate. You could, since this is a proportional graph, you could pick any one of those values right here, except 0, 0, to find the unit rate. Right here, I kind of want to pick that one. That would probably be the easiest, but I'm just going to challenge myself a little more. I'm going to pick like this one right here. So that's x, and this is y. Y is 290. That goes on the top. What was that? 290 what? I don't know. Was it distance or time? I don't remember. So let's check. Y is distance, so 290 feet. And then the x is, what does that say? 5 seconds. So that right there is the rate. So to find the unit rate, we want 1 in the denominator, 1 second. And I'm going to go ahead and have to divide by 5. Divide by 5. 290 divided by 5. Oops, I wrote wrong. 290. Whoops. 290 divided by 5. 58. 58 feet in 1 second. Holy cow. That's the unit rate. So oh, it's a Jaguar. Oh, no wonder they're fast. That right there is the unit rate. And they can go 58 feet per second. Okay. All right. So how far did the Jaguar travel after 20 seconds? See how it says 20 seconds right there? You got to use your equation. Well, hold on. Does it say 20 seconds here? Nope. But anyway, let's go ahead and use the equation. The 20 seconds, do you substitute it in for x or for y? Well, it goes in for x because seconds is independent and it's labeled right there. So I'm going to keep the y as a variable because I don't know how far it traveled. Keep your unit rate. Oops, that is supposed to say 58. Times 20 seconds. So 58 times 20. That far. 1,160 feet. I would hate for that to chase me. That's how far the Jaguar went in 20 seconds. It says which ordered pair represents the unit rate. So you see right here, this is the unit rate. Well, x is 1, y is 58. So right there, this right here is the unit rate. That represents the unit rate. So the ordered pair that represents it is the one with x equaling 1. So when you're like, oh, x equals 1, the corresponding y value is the unit rate. Remember that, please. Okay. All right, number 11. We've got another proportional graph right here because it's linear and passes through the origin. They want us to find the equation. I see that there's no points listed like there was up there. So I'm going to try to find, I'm going to label just a couple of points at perfect intersections. Well, that's not at a perfect intersection. Nope, nope. Oh, there's one. So that's at 3, 4. Let's see any more here. Oh, there's another one. 6, 8. Oh, there's another one. 9, 12. Okay, let's examine it. So this is the number of days, this is the number of inches, this is rising floodwater. Oh, okay. So after 3 days, we've got 4 inches of floodwater, it appears like. 6 days, you got 8 inches of floodwater. 9 days, you would have 12 inches of floodwater. So let's go ahead and find the equation. Y equals unit rate times x. And something that I hope you remembered to do was label your x and your y-axis, because it totally helps you label your equation. So x stands for the number of days, and the dependent variable is y, and that represents the number of inches, you know, of that flood water. Okay, let's go ahead and find the unit rate. You can pick any one of these ordered pairs you want. I don't really care. Let's go this one, 6, 8. So to find the unit rate, we go y divided by x, 6, 8. So y is 8. And I already forgot what y represented. Oh, it's over here, number of inches, so inches. And then this value right here is x. X is representing the number of days, so 6 days. Okay, so therefore we don't have the unit rate right there. We need to have 1 in the denominator, so 1 day. So 6 to get to the 1, we divided by 6, divided by 6. 8 divided by 6 is this right here. 1.3 repeating inches. And remember, 0.3 repeating is 1/3. So this is really 1 1/3 inches. And 1 1/3 inches is also equivalent to, let's see, 3 times 1 is 3, plus 1 more is 4/3. So in this little spot right here, you could write this, this, or this, and it would all be the same, okay? For the sake of this, I'm going to write this fraction right here because I don't really like dealing with a repeating decimal. So I'm going to keep it 4/3. The reason I'm not doing 1 1/3 is because I just don't have enough room, okay? So that right there is the unit rate, which is 4/3 inches per day. All right. So for this question right here, it says if the water was 60 inches high, how many days went by? So I see the water was 60 inches high, and I know that this is labeled number of inches, so that 60 is going to go right there. So 60 equals 4/3 times x, okay? And when we built this, we started with x, and then we just multiplied it by 4/3. So the inverse operation of multiplying by 4/3 is to divide by 4/3. So on both sides of that equal sign, you're going to divide by 4/3. 4/3 divided by 4/3 is 1. 1 times x is 1x, or x. And I got to go 60 divided by 4/3. So 60 divided by 4 fraction bar thirds equals 45. So how many days went by? 45 days went by. Okay, the last problem for the last part of this question. What's the ordered pair that represents the unit rate? And remember, when x is 1, that's the unit rate. But when I look right here, I see that that's not going to work out. So what you can do is, we could look right over here and see that this is days. There's 1 day right there, 1 day. And then the corresponding y value would equal this, this, or this. So that would be my ordered pair. 1, comma. When x is 1, what was y? Look at the y. It was 1 and 1.3 repeating. Or we could write it as 1 comma 1 1/3. Because remember, 1 divided by 3 is the same as 0.333 repeating. Or we can write it as a improper fraction, 1 comma 4/3. Okay, those would be all acceptable. Okay, for your summary, how do you know which point, which ordered pair represents the unit rate? How do we know that these points were the unit rate? How did you know that this point was the unit rate? Okay, bye.